We'll proceed in vector summation and integral calculus. Okay, vector summation and integral calculus, the area in which we have commenced a discussion, we have started a discussion. Vector summation and integral. Okay, we have seen that we can divide problem into n different parts. We can divide our problem into n different parts and then solve part by part and then sum it. I have a big problem. Divide the problem into small chunks and n parts. Solve the problem part by part and then assemble it. Okay, now we were doing it, but condition is that it must be through vector. That is a condition. It must be through the vector. Without vector, we would not like to do it. We were calculating the circumference of a circle through that way, and in polar coordinate system we did. Like if this is x-axis, then this is radius, and radius is moving like this. Radius is moving like this. Then if there is a radius, and this is the center, and radius moves like this, then it makes the circumference of the circle. The way it moves, it makes the circumference of the circle. Okay, what is the length of the circumference? To get it, there are two ways to do it. We have to divide independent component into n different parts. What is independent component? That is matter of concern now. Okay, if this is a circle, then one independent component is x-axis and y-axis is dependent component. Y equal to square root of a square minus x square. Y equal to square root of a square minus x square. If that is the case, then y is dependent upon x. X would keep changing independently. Okay. Now, if that is the case, if x keep changing independently, then I divide x-axis into n different parts. Claiming x as independent component, I divide x-axis into n different parts. Okay. First part, second part, third part, ith part, like that. Consider this is the ith part, it goes up and hit the circumference here. Okay, what is length of the circumference? This length of the circumference corresponds to ith part on x-axis. Length on the circumference corresponds to the ith section on the x-axis. If this is x-axis, this is minus a plus a. That this width is 2a by n. Okay, this is the circumference. Okay, another technology we use that, okay, let this is x-axis, this is y-axis. What about we have another guy that is called radius, and radius is moving like this. Then we have a something called theta. Theta is the axis that is formed by the radius. If someone watches it clearly, if radius move like this, then theta is changing. When theta is changing, it is making a circumference. Means the circumference, what we see, circumference is formed by theta. We consider theta as independent component. If theta is independent component, we are free to divide theta into n different parts. We are free to divide theta into n different parts. Okay, this is part number 1, part number 2, part number 3. These are the theta. Part number I. Like that I divide, and this is the part number n minus 1. This is part number n. Okay, I divide theta into n different parts. Now, if I take any arbitrary ith section, this is delta theta ith section, delta theta I. This is a theta with the x-axis. What is the parameter when it is delta theta I? We have calculated it. What is the parameter? Now, if I take from the vector perspective, okay, if this is the theta I, then consider this point and this point. Consider this point and this point. Okay, this point and this point. This point, consider it is P1 and this is P2. We have to find this length. This length we can say is found by delta theta I. If this angle is delta if this angle is delta theta I, then this is parameter I. I can write as summation I equal to 1 to n. Summation I equal to 1 to n. Parameter of the IS section. To find the parameter of the IS section, we get this point as P1, get this point as P2. If this is P1, then coordinate is R, comma, R theta. R theta is the circumference. Okay, this point is in polar coordinate system. This is both points should be perpendicular to each other. If I say any point is x comma y, then x axis and y axis are perpendicular to each other. If a pure polar coordinate system is not mentioned in any of the book, at least I have not seen personally. So if this is the radius, then if I talk about this point in pure polar coordinate system, then this point is r because this is radius r, comma, this is theta into r. This is x-axis, this is x-axis, this is angle theta. Then this length is theta, this angle is theta, this length is theta into r. Okay, now this point is r comma theta r. Okay, this should be perpendicular. It is certainly they are perpendicular. If I take about this line, then if I take at this point, what is the direction of the line? That is tangent at this point. Tangent at this point and this line, they are perpendicular to each other. Guaranteed in circle. So now we can write this point as theta comma r into theta. This point is r comma r into theta plus delta theta. If I take P1 minus P2, okay, this is P1. Now if I connect origin and this point P1, then this is P1 vector. This is position vector 2. If I subtract P1 minus P2, there will be a displacement vector like this. If I calculate the magnitude of displacement vector, more or less I get the magnitude of this length of this parameter IS section. Considering n tends to infinity, then delta theta I is 0, tends to 0. Then this section will be very small, and in that fashion, it will be equal to the straight line as per the approximation. Okay, in that fashion, now our summation is summation I equal to 1 to n. Summation I equal to 1 to n tends to infinity, length of the IS section. That is delta P of the IS section. Delta P is P1 minus P2. Delta P belonging to IS section, its magnitude. Okay, what is delta P? If we try to calculate the delta P, then one is r unit vector plus r theta plus delta theta unit vector. Another is r unit vector plus r theta unit vector. If I subtract, then we will get r delta theta unit vector. First component will go away if I subtract. Okay, then it will be summation I equal to 1 to n and r delta theta I. This is the length of the IS section, r delta theta I, where r is constant. If I proceed here calculating the magnitude of it, if there is a single component theta unit vector, that will go away. R delta theta I, r considering a function over theta, then function over theta into delta theta I tends to 0. Summation I equal to n, where n tends to infinity. It is exact case to bring it into integral calculus. Vector to summation and then summation to integral calculus. Perfect case to get it to integral calculus. Okay, it will become f theta d theta 0 to 2 pi. It will give 2 pi r. That is the radius. Okay, where r we have considered as function over theta. Next case we took, and r is variable. R is not constant. The way we are saying r is constant, r is going from here to here, r is going up. Consider that r is moving like this. So r is constant. Only theta is changing. Consider r is variable with theta. R is not constant. R varies with the theta. One case we have taken as r equal to cos theta. If I take r equal to cos theta, okay. If I take r equal to, let's take r equal to cos theta. We are accustomed of it. r equal to cos theta. In that fashion, if this is the angle 0, if this is angle 0, 0, then r is the r is 1. R equal to cos theta. R is 1. As angle is growing, r equal to cos theta, radius is decreasing. When angle is 90-degree, radius is 0. It has started like this and fall like this. It exactly makes the semicircle. Now when angle is growing 90-degree, then radius will grow again. And when angle is 180-degree, radius will come here, full phase 1 again. So it will form like this and this. But this radius is negative. Make sense? R equal to cos theta. If I say R equal to modulus, R equal to the absolute value of cos theta, absolute, R equal to vertical line cos theta. In that fashion, when angle is 0, then R is R. Then angle proceeds, then R becomes 90-degree. I'm sorry, theta becomes 90-degree and R becomes 0. When theta grows beyond 90-degree, then R becomes negative. Okay, whatsoever. So theta is going beyond 90-degree, and then we have r growing again, and r will come like this. At 180-degree, if I make theta, then r will start from here, and at 90-degree it shrinks to 0. From 0 it will go up, and at 180-degree it will become 1. But r equal to cos theta, r will become negative once it moves 90-degree. In that fashion, to make it positive, the way r is moving beyond 90-degree, we have to take reverse direction of the r. If this is the direction of the r, we will take exactly reverse direction. So this is the first semicircle, the next semicircle will form like this. Considering r as positive, this will form a circle. R is dependent upon theta. In that fashion, if we take, then we will proceed here delta p, same thing, summation I equal to 1 to n and delta pi, its magnitude. If I sum where n tends to infinity, if I sum like this where n tends to infinity, then it will give exactly as what is the circumference provided r is function over theta. We will proceed here again. What we did, okay, so if this is the ith section, if this is the r, then this is certainly not r because r is varying with the theta. So in that fashion, r will be little less. Okay, here r will be maximum when r touches the x-axis. Theta is 0. When r is moving, when it is at angle theta, then r has decreased little bit. When it moved delta theta I, r even decreased it. Now tell me, what is the section length of the arc when at the angle theta and delta theta I? Between delta theta I, what is the circumference? Now we can write same thing, summation I equal to 1 to n tends to infinity, delta pi. Delta pi is this position vector minus this position vector, which will give this delta p. Okay, in that fashion, if I take this point in the polar coordinate system, if this is r1, this is r2. If this is r1, this is r2. This is r2, this is r1. This point is r1, comma, r r1, comma, r into theta. If this is, if this, okay, if, okay, this is r1, hope, r1 theta. Just say r1 theta. Okay, any radius r of this point is r1 comma r theta. If I take this point, this is r2 comma r1 that travels delta theta I. Hope. Okay, r1 that travels delta theta I. Makes sense? This is false, you are saying. This is r1. If this length is r1 and this is theta, this angle is theta, then certainly this will not be r1 theta, because r is decreasing like this. Consider this point is r1, that is for sure. The radius is r1. This arc length we don't know. Okay, so we can say r1 comma some r into theta, or any quantity alpha, r1 comma alpha. If I move delta theta I, then whatever alpha we did here, okay, plus now this is r1, this is r1. So whatever we have now here, if I talk about this, whatever we have now here, that is alpha, we are talking about this point. This point radius is R2, comma, whatever we have here till alpha plus, plus, if this is R1, then R1 into delta theta I, R1 into delta theta I. If I talk about this delta P, if I talk about delta P, then it is this position vector minus this position vector is delta P. This position vector is R1 R unit vector plus alpha anything alpha theta unit vector minus R2 R2 R unit vector plus and then alpha plus R1 delta theta I theta unit vector. If I subtract, it becomes R1 minus R2 R unit vector plus R1 delta theta I theta unit vector. This is how it will be. Okay, R1 minus R2 I can write as delta R. With that much radius change. If radius R1 is this much, R2 is this much, while traversing for the delta theta I, radius changed to delta R. That is the difference I am seeing. R1 minus R2. Now it is the delta P vector. If I talk about delta P vector, then it is delta R R unit vector plus R delta theta theta unit vector. If I talk about the magnitude of this, it will be delta R whole square plus R delta theta whole square root. Now we can rewrite as the length of this circumference is summation I equal to 1 to n tends to infinity. And then the length of this delta P vector, that is the square root delta R whole square, delta R of the ith section. This is ith section. I divided this angle into n different angle. This is the ith section, delta R of the ith section whole square plus R delta theta I of whole square root. I can take out delta theta from here. Then it will become delta theta I into a square root of delta R by delta theta whole square plus R square. R1 I can say R square. R. Okay, it becomes like a square root of d delta R by delta theta of the ith section whole square plus R square. Okay, R is actually the beginning one. R square root into delta theta I. Okay, then it is like that. Now someone can compute it. Now it is coming in the same phase. Delta R by delta theta tends to 0 will be dr by d theta only. The square root of dr by d theta whole square plus r square root into delta theta I. It is exact case as function over theta. Dr by d theta will be function over theta. Function over theta into delta theta I. If I sum it for I equal to 1 to n tends to infinity, it is fit case to transform into integral calculus. Function over theta d theta, function over theta d theta, and then integration theta 0 to pi, 0 to pi, because angle it is moving 0 to 90 degree and pi degree, that's it. And in that only it is making a circle, r equal to cos theta, 0 to pi. If someone calculate it, then he will get the circumference. What is that? Function over theta is the square root of dr by d theta whole square plus r square d theta. Theta is 0 to pi. He will get the circumference of a circle which is formed by r equal to cos theta, and that is a circle. Someone is seeing that is a circle of radius 1 by 2. This radius, the center of the circle is here, not at the middle, here. This length is 1 by 2. It forms a circle where left end touching the origin, and then radius is 1 by 2. This will give the circumference. Now people would say, can you corroborate it? Can you prove it through you took the vector fundamental, and as per the vector fundamental, you took 2 points P1 and P2. P1 point is r comma r theta. P2 is also r comma r theta. This is typically called as polar coordinate system. Okay, there is another polar coordinate system. If I do XY coordinate system and polar coordinate system hybrid model, then X equal to R cos theta and Y equal to R sin theta. Any point here, I can demonstrate it as X comma Y or R cos theta I plus R sin theta J. Okay, can you prove that it will come like that one? Okay, take your example R equal to cos theta. R is a variable with cos theta. R is a variable with cos theta. The way we are saying, proceed proceed in same manner. Okay, then this is origin, this is origin, this is origin, and this is x-axis and this is y-axis. Consider any point x comma y. Okay, if I move any point x comma y, if I take, I now I chop it into n part from x-axis point of view. Now, if I taking x and y, if I am taking, then x is independent. Or if I taking a hybrid model, then someone can take theta also as independent. If I move in theta, then now I am at ith section. If I am at ith section, then this is the parameter of the ith section belonging to delta theta I. This is the parameter of the ith section belonging to delta theta I. Okay. Now, if this is the parameter and this delta theta tends to 0, if delta theta it tends to 0, this parameter will behave like a straight line. If angle is very small, then local linearity, it will make this angle as a straight line. If this is a straight line, then it has two components. This component, horizontal component and vertical component. Makes sense? If I have a straight line like this, beneath it there is a x-axis, then from here to here, if I draw like this, it will hit x-axis. This is x component. If I take like this, from here to here, I draw like this, it will hit y component. X-axis, y-axis. Okay, if that is the case, then what is the length of this line? If this is x, then x square. Or if I say this is delta x and this is delta y, because we have taken this length as what is the parameter? Summation I equal to 1 to n tends to infinity. Parameter of the ith section. I'm not saying delta p. I'm trying to prove it that what we said, that it is square root of dr by d theta whole square plus r square d theta or delta theta I as per our polar coordinate system, it is perfect or not. If that is the case, then if I take any delta theta I other than vector, if I take any delta theta I, then this is the arc. If delta theta I tends to 0, then this arc will become a straight line. Then this arc, if I take, it has the straight line, and the length of this straight line is very small because this angle is 0. If I map this straight line on x-axis, this is delta x. If I map this straight line on y-axis, that is delta y. What is this straight line length? Delta x whole square plus delta y whole square. Okay, now we can rewrite as summation I equal to 1 to n square root of delta x whole square plus delta y whole square. That is the length of the ith section. Okay, if now delta x whole square of the ith section, delta y whole square of the ith section, where delta x tends to 0, means delta y tends to 0. If that is the case, then we can rewrite as dx whole square plus dy whole square if I take into integral calculus. Okay, sorry, sir. Integral calculus must be in fx into delta xi. Then only you can convert it to integral calculus directly. Otherwise, it's not possible. A square root of delta xi whole square plus delta y whole square root. Considering y is a function of x, this will come as fx, function over x. Where is your dx? It's missing, not possible. Okay, we will do one thing. We will take out delta x here. If I take out delta xi here, it will become a square root of 1 by delta y by delta x whole square and then delta xi. Net summation will become summation I equal to 1 to n tends to infinity and length of the ith section. There is no vector involved here. Okay, square root of 1 plus delta yi by delta xi whole square and outside delta xi. Now it is fit case. This first square root term is function over x and next is delta xi. Now I can convert it to integral calculus fx dx. Now this is a square root of 1 plus dy by dx whole square dx. Will it become dr by d theta whole square plus r square root d theta the way we brought through vector fundamental? That is the question now. I believe it is alright. Okay, what is dy by dx? What is y? Y is r cos r sin theta. What is x? X is r cos theta. What is dy by dx? Dy by dx I can rewrite as dy by d theta. Dy by d theta into d theta by dx. Makes sense? Same thing. Dy by d theta into 1 by dx by d theta. Okay, if someone goes through dy by d theta, if someone goes through dy by d theta, okay, dy by dy by d theta, how much it will come? Y equal to y sin theta, r sin theta. Dy by d theta will become r cos theta plus sin theta dr by d theta into d theta. I believe it is all right. Okay, into d theta. Okay, what is dx by d theta? Dx by d theta. If someone calculate it, it will become x equal to r cos theta, r minus sin theta plus cos theta dr by d theta. Okay, now someone has to divide it and then calculate the square of it. Okay, someone would say, why you are in this much trouble? You can directly take a dy by dx whole square, dx this side, and take out dx from there. More or less, it will come as the square root of dx whole square plus dy whole square for simplicity. But for the a kind of happiness of the mind, someone for the solace, then someone can compute like this. It's free. Okay, in that fashion, dy by d theta is r cos theta plus sin theta dr by d theta. Okay, divide by r minus sin theta plus cos theta dr by d theta whole square 1 plus. Someone settle it down. Okay, if someone settle it down, the whatever we have denominator, this will come as 1. Okay, d theta nor numerator we have at the end d theta, denominator we have at the end d theta gone. Okay, dx whole square, if I settle it down, square root of 1 plus dy by dx whole square, whatever we have dx by d theta whole square, it will come to 1. And then if I take it as a square root, it will come as denominator dx by d theta. Okay, outside we have dx. I can convert dx to the same as dx by d theta into d theta. More or less they will cut down. Right side we will have d theta only. At the end it will come as dx by d theta whole square plus dy by d theta whole square root. That it will come. What is dx by d theta whole square? It will come as, I believe it will come as r square sine square theta plus cos theta dr by d theta whole square minus 2 dr by d theta sin theta, something like that. Okay, someone can try. Dy by d theta whole square, that will come as r square cos square theta plus sin square theta or dr by d theta whole square. Okay, and then plus whatsoever. This plus and minus they will cut each other, and then cos square r square cos square theta plus r square sin square theta will become r square. Okay, and dr by d theta sin square theta whole square plus dr by d theta cos square whole theta, that will become dr by d theta whole square. More or less it will come as the square root of r square plus dr by d theta whole square plus outside d theta. Same. Miss, our polar coordinate system vector fundamental, it really works. It really works. Okay, understood. It really works. Can you use this fundamental to calculate the surface area of a circle? I mean, the area of a rectangle. The way you are talking, can you use this vector fundamental to calculate the to calculate the surface area of a circle. What is surface area of a circle? Surface area of a circle, if I take now I have to cut, if there is a surface area, if there is a surface area, then there are two vector will be involved. Surface area has two sides. One side I can say it is like this. Okay, what are the two entity that is variable here if I take surface area? One is the arc, means theta is variable, and one surface area, not the circumference. Okay, and then radius is variable. Radius will start from 0 and it will go till a. Radius is variable and angle will go from 0 and it will go till 2 pi. Now use vector to calculate this area. That is the concept. We will do same thing. First we will use vector. The first we will chop into n part. If I have a theta angle, or someone can take it as an assignment to calculate it. Now, if this is angle theta, then angle theta we will chop into n different parts. Okay, means if I have a circumference like this, circumference is chopped into n different parts. And if I have a radius, then I'll chop the radius into n different parts. Makes sense? Then we have sub area. Small sub area is formed. Imagine how the sub area would be. If I chop this radius into n different parts, if I take any jth section, then this is the length. If I chop the circumference into n different parts, if I take any ith section, then it will be like this and this radius and this radius. This is the sub area it will form. Okay, if I chop a radius into n section, then one section I'll take. Then if I chop the circumference into n section, one section if I take, then if I add these two, it will form a very peculiar area. What is peculiar area is that it will be like this. Up. It will be like this. It will be like this. Okay, means this is one arc and this is another arc. This is delta r. This is delta r. This is delta r. From here, this is center. This is one r. This is jth section of the r. This is the radius of the full r. I chopped into n part. Then I take any jth part. Similarly, the circumference that is passing here, circumference is passing from all the location of the radius. Circumference that is passing here, I chopped into n part. This is the ith section. It will form like area like this. Okay. Now, if someone is watching closely, there are two vectors. One vector is created. There are two lines or two vectors. One vector is if I there are two vectors. One vector is formed. Now, what are the points? This is P1. The way we took. This is P1 and this is P2. If I subtract P1 and P2, it will give me this vector that is along the arc. That is delta P vector. This is delta P vector. If I chop the radius into n part, here theta will not change. R will change. R is from here to here. R will change. But here we can say R is also changing. If I go, let's take R is constant. We are taking full place circle where R is constant for simplicity. R is constant. If R is constant, then this is delta P. This point is at any moment consider this from here, this is R. Then this is also R. This is the origin. This is R, then this is also R. This is R comma theta. And this is R comma delta theta plus delta theta. Same thing. Delta P will be R comma delta theta I. This angle is delta theta I. The way the circumference is chopped. Makes sense? Okay. Now in that fashion, okay. Now what about this? There here till here, if I say, then this is the jth section. If this is the radius, then this radius minus this radius, that is the radius of the jth section. Here there is nothing called theta, only radius is there. I call it delta r. Okay, now we have two vectors, delta r, okay, or radius till the jth section and radius if this is the jth section, this is the first section. What I'm trying to say is that if this is a circle, then this is the radius. If this is a circle, then this is the radius. I chop this radius into n different parts. I'm talking about the jth part. Similarly, if this is the angle, then I chop this 2 pi 360-degree angle into n different parts. And then I'm talking about the ith part. This is the ith part. If I talk about the ith part, then ith part will converge at the origin. Okay. And then if I take the radius, then I take only jth part of the radius. I chop it into n part, jth part and ith part. In that section, if I take, then this section will come. Make sense? Which will confirm our delta theta I also and delta R also. What about now if I take this point here, this point and this point, consider the instantaneous radius is R because radius is here till here. That is consider that is A. A is the radius of circle that is fixed. Instantaneous radius up till here is R. Instantaneous radius up till here is R. Okay, if I take this vector, then this is P1 minus P2. That is P1 minus P2 delta Pi will be R into delta theta I, where R is variable because R is varying up till here. And if I take about the jth section, then that length is this radius minus this radius, that is the jth section, that is delta R. Okay, if I do cross product of these two vectors, that is at anyway at 90-degree only, no need to do any much computation. So we can directly come as delta R into R delta theta I is the area of that portion. Now I can write as the what is the area? This summation I equal to 1 to n, summation j equal to 1 to n. I is the cutting the theta degree into n part. Summation j equal to 1 to n, cutting the r into n part. And then the area of ith jth section. The area of ith jth section is delta r belonging to jth section, r unit vector, cross product r delta theta belonging to ith section, theta unit vector, r vector cross theta and then its magnitude. R vector and theta unit vector, their cross product will be a vector that will be perpendicular to the surface. But anyway, if I take, so there will be one vector. If I take modulus magnitude, that will go away. More or less, it will come as R delta theta I delta Rj. Okay, summation I equal to 1 to n, summation j equal to 1 to n. R delta theta I delta Rj. Now, someone can take as an assignment how we can. So we started from the vector. One vector is delta p. So what is the area of ith section? That is cross product of delta p of the ith section cross product delta r vector delta r of the jth section. That came as r delta theta I delta rj. Now we have summation I equal to 1 to n tends to infinity, j equal to 1 to n tends to infinity, or j equal to 1 to m tends to infinity, whatever it is. Now area of the ith section, that is delta pi cross delta rj, that came as r delta theta I delta rj. Okay, n tens. Now someone bring it to the integral calculus. If I take x-axis as r theta, consider that I have a plane, I have a plane, I have this, consider this is theta axis and this is r axis. This is a theta r plane. If there is a theta r plane, if there is a theta r plane, then consider there is a function over theta and r. What is function over theta and r? D theta dr or d theta r, d of theta r plane. Function over theta r, that will be, if this is theta r plane, if I take function over theta r, that will be vertical component. Now we land up into 3D. So function over theta and r is a vertical component. And then theta r plane is this function over theta r d theta r. How to compute this? This will calculate the volume underneath it. Okay. Now let's take a single axis called theta r axis. Theta r axis. Then function over theta r axis will be vertical component. Okay, in that fashion, this is theta r. Okay, now I can chop this theta r into m into n part, m into n part. Each part, now I can say delta theta r. If this is delta theta r, then their height is function over theta r. If I multiply, it gives this subsection. Okay, then if I add for all, it will exactly become f theta r d theta r. Someone can think in the 3D manner also. If this is delta theta, this is delta r, then I have a sub area delta theta delta r. Then vertical component is function over theta and r. This is the volume. Or someone can take in single dimension. Single dimension is more clear. So in that fashion, function over theta r d theta r delta theta r will exactly map into integral calculus. Function over theta r d of theta r or d theta dr, where the theta r begins from minimum to maximum. In theta r plane, theta and r minimum to maximum. Now theta and r are independent to each other. R is going 0 to a and theta is going 0 to 2 pi. We can write theta 0 to 2 pi, radius 0 to a. What is function over theta and r? Function over theta and r is r only. I don't know if it will come or not. I'm trying. It will be r only. And then d theta r, d theta dr, r square by 2, 0 to a square by 2, and d theta will be 0 to 2 pi, 2 pi, pi r square. That is the area. Okay, mind blowing, amazing. I was shivering, it will come correct or not. So we can use vector to calculate the area of a circle. We will proceed on this. These kind of things are purely on experimental basis of using the vector terminology or something like this. Why we are making it repeated again and again? Because once we start the machine learning and artificial intelligence, we will see different functions. But we will now map it to what we have learned here, calculation of surface area and this and that, so that quickly we can transform into vector and this and that and solve it quickly. Okay, please don't mind supporting us. +91 is the India country code, plus 9483160610 is the telephone number. Or please mind supporting us. +91 is the India country code, 9483160610 is the telephone number.